Well, putting it all together, here's our first objective. I can evaluate expressions with the order of operations, meaning now we're looking at all four operations now. Not in all the problems, by the way, but we'll have a process for that. Now, the order of operations is very nice because it will keep things in order for everyone, meaning everyone will be doing the problems the same way, which will give us a uniform answer. Otherwise, if everyone was just like, you know what, I'm going to do it my own way, then it really jacks things up. And then we got to be able to translate and solve the work problems as well. Now, the order of operations, I'm going to start with that note at the bottom. Not always PEMDAS, okay? So PEMDAS, while it is very easy to remember, and in fact, I think if you went onto YouTube, you could probably find music videos about PEMDAS. You get to decide how entertaining they are. But PEMDAS is nice. However, if you look at, let's go through the steps, in fact. So parentheses, okay? Now, parentheses, we've seen the parentheses with the associative property of both multiplication and addition. But if you were to see, this goes back, but these are absolute value parentheses. Okay, if you see absolute values, they become parentheses, meaning you must do them first, just like you would a regular set of parentheses, like we're showing here. Now, parentheses also, just because I can't guarantee what they're going to show, but I have seen math programs in the past which use square brackets like this as parentheses. So if you see either these square brackets like this or regular parentheses like this, they're all considered parentheses, meaning whatever's inside there, you got to do it first, just like the absolute values will. This is a fraction line. We shouldn't see a lot of fractions. Well, I guess we could because we've done some division, which means you have to do the top or the bottom first, and then you do the one you didn't do second. Okay, so it becomes kind of its own set of parentheses. You have to evaluate top and bottom separately, and then you can use the division. So parentheses, kind of a few different ways to look at parentheses. Exponents, which we've seen, you'll have a base and an exponent. Okay, the exponent just tells you how many times to multiply the base by itself. And this is where PEMDAS becomes a little wishy-washy, because notice it's an or statement here. So a multiplication or division from left to right. So just expect this because it almost always happens on some kind of exam. They're going to do something like, 12 divided by 4 times 3. Like this. And students will usually do the 4 times 3 first because of PEMDAS, all right? Which you shouldn't do because it's either multiplication or division starting or scanning from left to right. So from left to right, see the division is first on the left. You have to do the division first, not the multiplication. Because if you did the multiplication, you're going to get, well, I guess you'd get 1 first, or overall. But with the division, you're going to end up with a 9er on this, okay? Which are very different answers. But the 9 would be the correct answer, not the 1. So you got to be careful with this. You have to do this division first because it happens first on the left. Now, if it were switched, I don't know, 2 times 4 divided by 8, okay? So this is okay to do the multiplication first, but it's not because of PEMDAS. It's because multiplication is happening first on the left. So it can be either one, okay? But again, you're scanning from left to right. Oh, there's division first. I have to do it. Scanning from left to right. There's multiplication. Oh, I got to do that one first, all right? So it's multiplication or division from left to right. And then addition or subtraction as well. This is where the A and the S can be mixed, or like we've discussed already, the D and the M can be mixed. So it could be PEDMAS, or it could be PEMSA. Which I don't care that I'm jacking that up, but you understand what I'm saying here, because it could be addition or subtraction, meaning you may have to do the subtraction first, whichever one happens first, scanning from left to right. So I'll give you an example again. If you had 10 minus 8 plus 1 right here. Some students like, boom, there's my PEMDAS. Well, A is addition, so you got to do the addition first. No, you should not do that addition first. You would not do 8 plus 1 first. You'd have to do the subtraction because it happens first, scanning from left to right. So, this one I scan here, going from left to right. Oh, there's my, subtraction, which is first on the left, so I must do it first. Okay? So while you're going through the order of operations, parentheses, exponents, multiplication or division, we're not really worried if there's any addition or subtraction yet. So if you see some, it's not that you're skipping it, you're just ignoring it until you get into that step, all right? Now the parentheses thing, this is where students can get confused as well. Sometimes you're going to see more operations inside a set of parentheses. You have to do everything on the inside of the parentheses first. So if you see parentheses and there's stuff inside, you have to essentially restart the order of operations, but just within that set of parentheses. That may not make a lot of sense, just kind of explaining it verbally, but let's see if some examples help. Not on the slide, but it should have. Apologies. If you see a square root, it pretty much goes down as a set of parentheses. So if you ever see a square root, you pretty much have to do it first. Now again, sometimes you'll see parentheses within parentheses, and again, whenever you're looking inside a set of parentheses, you're just restarting the order of operations. That's it. All right, so this is what I was talking about. This is one of those, it's not meant to be one of those I got you math questions, but it gets students, you know what I'm saying? So math people aren't like, let's see if we can just stick it to students. No, this is one of those where let's make sure that they get the order of operations here. Now the order of operations would be parentheses. Okay, there is no parentheses, so don't worry about that one. I don't see any exponents, and I hope you don't either, because I don't. So there's no need for exponents here. So that brings us to multiplication or division from left to right. And scanning from left to right for my operations, boom, there's my first operation to the left, which is division. And well, anything divided by 1 is itself, so it ends up being just 22. And then we can rewrite the rest of the problem. So you see how the 3 just kind of drops? We didn't do anything with it. So it just drops as a 3. Okay, well, then it's 22 times 3. Yeah, 66. So I'm going to show the work, though, because, it's fun. So 22 times 3. 3 times 2 is 6, and 3 times 2 is 6. Boom, 66, done. Okay, now that we got a nice value there because we followed the order of operations, what happens is if you do this out of the order of operations, you'd get 22, you'd do 1 times 3 first, then you'd get 3, and 22 divided by 3 would be 7 with a remainder of 1, which we don't want. That would be incorrect. But you would get 7 with a remainder of 1 because it was out of order, which, again, we don't want. So no parentheses, no exponents, but the first operation, you can scan it from left to right, but we have to skip the addition because there's multiplication. So we have to do this multiplication first. 4 times 6, 24. Now we can look at that addition part. Last of all, 5 and 24, well, 24 plus 5. You use fingers to do this one, by the way. 24, 25, 26, 27, 28, 29. And that would give you our simplified answer. Bam. Did this out of order, which we don't want you to do, but I'm just giving you an example. If you did this out of order, you probably did 5 plus 4, which was 9. Okay, then you'd have 9 times 6, which would have been 54. And yeah, that's a common error, even on a problem like this one, which, again, we don't want you to do. Let's learn from those mistakes and keep it in order. A little bit of a square root right there, right? If we're looking at this one and we're saying, yeah, we're going to start with parentheses, we'd have to look at the biggest set of parentheses right here, okay? Now, inside this set of parentheses, and you know what I'm going to do? I'm going to cover up this stuff on the outside because I don't even care about it right now. We're not at that point yet to worry about it. But what I have is this is the square root of 81, and then I got another set of parentheses, 9 minus 7 to the power of 2, which means that I really am looking at two sets of parentheses, meaning that's square root here, which is poorly drawn, but I did my best, is its own set of parentheses. But we also have this other set of parentheses right here. I don't really care about the exponent because I have two sets of parentheses which I can work with.
So it doesn't matter, you get to pick.
We're going to do 9 minus 7, but we can do this one first because specifically this is a multiplication in between. Okay, now 9 minus 7, you can do the work over here. 9 minus 7 is 2. 2. Now, that came from the 9 minus 7. So now instead of, remember math is what we want. So I don't want to show 9 minus 7, so I'm just going to show a 2 right there. Okay, so let's rewrite the rest of this. It's the square root of 81. Again, I put that multiplication there. It doesn't matter. It would have been there whether we can see it or not. And then it's to the power of 2. Again, I don't care what's on the outside of my big set of parentheses, the red ones. But at this point, there's nothing else I can do inside this set of parentheses. So it's just a 2, meaning that I've got to take the square root of 81 right now, which is 9. Now, this inside of the red set of parentheses would read 9 times 2 to the power of 2. Because it's being multiplied.
Wait, almost.
So we talked about square roots, I think last time. I think it was 1.6. But the square root of 81 is asking what number times itself is 81. That number is 9. So the square root of 81 is just an individual 9 right there. So a common mistake at this point is where we see students do the 9 times 2 right here, which is now out of order on the inside, right? We did some parentheses here and here. Now it's exponent time, and there is an exponent right there. The 9 is not applied to the exponent of 2, okay? 2 to the power of 2 is really 2 times 2, which is 4. Now it would be 9 times 4, which would be 36. And that's all that we have now inside the red square bracket. So go back to the top. Let's take that box off. And now the problem would be 24 divided by 3 plus that red square brackets right there. So this is the great thing about the order of operations, in my opinion, is that what it does is it takes something really large and fairly ugly, and then we focused on one part of it at a time in order to make it smaller. Which, as it turns out, is what they say makes really good problem solvers. They can take a big problem and then separate it into smaller, more manageable parts, which is what we just barely did. So having this now right here means that everything that we've done, which was good, now has changed the problem into this. So if we had started with this, we would have been like, oh, that looks great, and we can do it. But now you may expect to see some problems where you have to get to that point, like this one. So in this problem here at the bottom, there is parentheses, but there's nothing to do inside. There is no exponents. So yeah, we're at the point where we must do this division right here. And 3 will go into 24 exactly 8 times. Okay, so we'll add that to our 36. Still using the square bracket so we know where that came from. But last of all, we just do 8 plus 36. So over here the work, 36 plus 8. 6 plus 8 would be 14. Carry the 1. 1 plus 3 is 4. So our final answer after all that is 44. Yeah, let's go back and do that. So 24 long division divided by 3. So 3 does not go into 2. So I should have shown this already, but I'm not worried about the 4 right now. Right? We move in long division, we move from left to right. 3 does not go into 2. So I put the 0 there just to hold that place value. and then we have to look at it as 24. So 3, how many times does it go into 24? You can use the multiplication tables for this. You'd say, well, you'd have a 3, 6, I'm skipping the addition on this. Thank you. So 3, 6, 9, 12, 15, 18, 21, 24. That's the 8th multiple. So 3 goes into 24 exactly 8 times. 8 times 3 is 24. So when I subtract, nothing remaining. Boom. So that's this 8 right here. I guess I should have done it in green, but that's the green 8 right there. Okay, on this one, just to start, parentheses first. Now, some students get caught up with these parentheses right here, but there's nothing to do on the inside of those parentheses. So I'm gonna skip those. Really what it is you have multiplication between them, okay? And I'm gonna skip over here to this set of parentheses. Which means that as of right now, I'm ignoring everything on the outside, on both sides of it, okay? We'll get back to that stuff, but right now, let's just focus on the inside. Now, on the inside, there is a square root. So we have to start with the square root because it is considered a set of parentheses. Now that's 16. That reads the square root of 16, but the question is, what number times itself is 16? Well, and before. Very good. Okay, so that it now reads inside 4 plus 56 divided by 7. Now just going back to a couple slides back, some students would do 4 plus 56 here first, but that is out of order. We just did parentheses. There are no exponents, so we have to do multiplication or division. And yeah, there's the division right there. So we must do it before we do any addition. So how many times does 7 go into 56? Bam. Now we have 4 plus 8. And since there's only one operation, well, 4 plus 8 is 12. I'm going to keep that in parentheses because all we did is we took this stuff on the inside and we simplified it into one individual value, which is good. That's what we want. Let's get rid of these boxes and see what's on the outside. And let's rewrite this. That's a better 5, I guess. Okay, so that's parentheses. Okay, now again, what this means is that you pretty much could have started here, but we had to make it get to that point. So let's show the rest of the work. So at this point, for this line right here, we have taken care of all of our parentheses. There are no exponents, but there is some multiplication between the 9 and 5. So 9 times 5, 9 groups of 5 would be 45. And, well, I need to show the rest of the stuff. Okay, so we got 3 plus 45 minus, again, I'll keep the 12 in parentheses just so we know where it came from. And then plus the 45. So that is the multiplication. There is no division, by the way, or other multiplication. So we're done there. What I would do at this point is I'd probably get rid of the parentheses on the 12, just so we know that it's all we're dealing with at this point is addition and subtraction. So since we're on the addition and subtraction operations, we work from left to right. So the first addition here on the left, 3 plus 45, so you can stack and add. 45 plus 3, 5 plus 3 is 8, drop the 4 is 48. Okay, then we just take the rest of that, drop it down. There we go. So there's our addition. We're still moving from left to right, and the leftmost operation now is the subtraction. It's 48 minus 12. So we'll show the work here on the left, 48 minus 12. 8 minus 2 is 6, 4 minus 1 is 3. So that would give us 36. And then last up, we got to do the plus 45. So we'll do that work. 36 plus 45. So in the ones place value, 6 plus 5 is 11. Carry the 1 into the tens. 1 plus 3 is 4, plus another 4, 81. So we end up with 81. Done. Now that may seem kind of weird, thinking about what we started with. But again, the order of operations helped us to break that up into smaller parts so that as we move down, we ended up with something smaller and then something smaller. And this would be considered, we call this 4 terms. And then you have, well, 4 terms, then 3, then 2, boom, then 1. Translating operations and equations. So we've seen all this stuff. I just copied and pasted this stuff from previous slides that we've seen already. But what we haven't seen is equality, which is just an equal sign, right? So of course we know addition is kind of like a T looking symbol, and then subtraction is minus sign. Division is a minus sign with 2 dots around it. And then multiplication, we just use 1 dot. Equality, though, is an equal sign. So here are some ways that you may see equality in some of these problems. They'll say is usually represents an equal sign. Or they'll say equals, which is fairly convenient. The same as, totals, sum of, difference of, quotient of, product of. When it's talking about sums, difference, quotients, and products, it's telling us what it equals, but it's also telling us what operation is being used. Sum, like we can see above, is addition, difference is subtraction, quotient is division, and then product is multiplication. And that's it. We do need to remember, for subtraction, if we see less than or subtracted from, then it reverses the order. Just like division, divided into will reverse the order of the values given there as well. This one is not asking us to solve, so don't worry about solving. Let's just make sure that we can translate this. Let's see how you did. I'm going to do this wrong first. Wrong. Okay, so this is not what you should do. But if it's what you have, let's learn from it, okay? So 46 less than 73 is, there's our equal sign, 27. This would be incorrect. Now you could just actually calculate it and see that it's incorrect. But the less than, so let's get rid of this stuff. Less than, it is subtraction, but again, it reverses the order, meaning the 46 here has to come second, and then 73 has to come first. If we ever see the word is, it usually indicates some form of an equal sign, and then they just said it's just 27. Which is true. That actually is 27. There we go. There's nothing to solve here. We're just making sure that we can translate this stuff like we just did right there. I mean, in the future, what they're going to do, they're going to say, hey, look, what is this number right here? All right, well, then you'd have to find out that it's 46, probably with a fact family, but we'll cross that bridge if we need to. Okay, let's translate and solve this one because it's got a question mark in there. We're looking at a quotient. So we're going to put a division symbol in there. Now, it's the quotient of 44, so that has to come first. If it said it was, it says divided into, then it switches the order, but a quotient should be pretty direct here. It's the quotient of 44, and then we got this question mark. If we see the word is, we're looking at an equal sign, and it is 4. This is the translation. Now, in solving it, though, we would switch the order up. We're going to switch the operation into multiplication. So the dividend in the multiplication problem is going to be the product. So there's my 44. There's my equal sign. And then the divisor and then the quotient become factors. I don't think that helped. It didn't. Yeah, it'd be 4 times question mark equals 44. Maybe that does help. What I needed to do is go back to the division problem. So that's a dividend. We're going to keep division. But I can switch the quotient and the divisor. So then it'd be 44 divided by 4 equals question mark. Okay, well, let's use some long division here. That should help us find that question mark. It's going to be 44 divided by 4. So 4 will go into 4 once. 1 times 4 is 4. When I subtract that, zeroes out, so drop this 4. How many times is 4 going to 4? Once. 1 times 4 is 4. Nothing remaining. So the question mark, let's go and replace that, ends up being 11. That's the quotient, which means the value that was missing, the question mark, is just 11. Not completely sure how that's going to show up on the assignment, just maybe that's like a box right there. Or it's just a box you just put 11 in, whatever. You go on a 3-day, 50-mile biking trip. The first day you bike 21 miles. The second day you bike 20 miles. How many miles did you bike on the third day? All right, so the 3 days thing is only useful because we have the first 2 days, but we're just missing the third day. So I'm just pointing out that the 3 right there really is not going to be so helpful. How many miles did you bike on the third day? So we're going to take the first 2 days, and we're going to add those together. So, I'll write it over here. 21 plus the 20. This is how many miles you've gone after 2 days, which would be 1 plus 0 is 1, 2 plus 2 is 4. So after 2 days, you've gone 41 miles, but you're going on a 50-mile trip. So we're going to take the 50 miles. And to figure out how many miles you need to go on that last day, we're just going to simply take the 41 and subtract it. This will tell us how many miles you need to cover on that third day, which is much less than the other 2, and that's okay. But I'll borrow 1 from the 5, make that 10. 10 minus 1 is 9. 4 minus 4 is 0. So how many miles must you bike on the third day? 9. And don't forget your label, 9 miles. Boom. But some students, they like this method. I like it too. Some students like to say, well, 50 minus 21 is, 29, and then they minus the 20 to get 9 miles. Doesn't matter. See how you get the same answer, though? That's what we're trying to say. You should get the same answer no matter which method you're using. You decide you need a new computer. The cost of the computer is $576. However, the store also offers a rent-to-own option, which will cost, I assume, $29 per week for 24 weeks. How much more will the rent-to-own option cost after you have made all of the payments? Try this one out. Got a few operations in there. Try it out, and then we'll see how you do. Okay, so we got the regular cost of the computer, boom, $576. Or you can rent it, $29 per week for 24 weeks. So that's 24 groups of 29, which means we're using multiplication. So 24 times 29, I'll need some space there. Let's stack this up. 24 times 29. And let's start multiplying here. So in the ones place value, 9 times 4 would be 36. But I'm going to carry the 3 over to the next place value. Then I would have 9 times 2, which is 18. But I'd have to add the 3 to make that 21. Now that's just the 9 times the 24. But then I've got to do 20 times 24. So again, no ones here. But then I would have 2 times 4, which is 8. And 2 times 2, which is 4. And when we add these together, that will tell us how much money was spent on the 24 weeks of renting this rent-to-own the computer at $29 per week. So 6 plus 0 is 6. 1 plus 8 is 9. 2 plus 4 is 6. So after 24 weeks, you would have owned the computer for $696. Now that's not our answer, but at least tells us how much it would have cost to have rented the computer. Yeah, so to figure out how much more the rent to option own costs after you've made all the payments, well, we know it's bigger. So how much more is actually a subtraction problem. Okay, so we're going to take the 696 and we're going to subtract the original cost of the computer, $576. So how much how much more money did you spend by renting? Well, the subtraction, 6 minus 6 is 0. 9 minus 7 is 2, and 6 minus 5 is 1. You would have spent an extra $120. Read scenarios A and B in each row. Determine if the answer to the two scenarios are equal. Explain why. Okay. You make 3 toys an hour for 8 hours. How many toys did you make? Well, this is, I'd say it's 8 groups of 3 for part A. So 8 groups of 3 would be 8 times 3, meaning in those 8 hours, you would have made 24 toys. Okay. Well, that's A. B says you're going to make 8 toys for 3 hours. So for me, I would say that's 3 groups of 8. And 3 groups of 8, still 24 toys. So the last question, are the numerical answers the same? The answer is yes, of course, because it's 24 toys. But we'll explain why it's yes, okay? Because, well, this takes us back to the properties of, in this case, multiplication, which we'll say it's the commutative property of multiplication. There we go. Right? The first one in purple is 8 times 3, and then it's 3 times 8. So the order just switches, which is a commutative property. So read scenarios A and B in each row, determine if the answers to the two scenarios are equal, and then choose the correct answer. Fair enough. A, you travel 300 miles in 6 hours. How many miles did you travel per hour? Okay. So this would be, the per right there indicates division, by the way. And that, some of you may, that may answer the bottom question. But it's talking about miles first, and it's saying you went 300 miles in the 6 hours. So it'd be 300 divided by 6, which we can use long division here. So 300 divided by 6. And 6 won't go into 3, but it will go into 35 times. 5 times, so there's a 0 there. 5 times 6 is 30. So that was all used up. But dropping that 0, 6 goes into 0, well, 0 times. So this means that you would have been traveling at 50 miles per hour, which I'm just going to show as mph. Pretty fast, you know. In my mind, for some reason, you're running, that makes it really fast. But now we go to the next one, and we say per, which indicates division. And it's miles per hour again, but this time the miles is 6 miles, right? So it's 6 miles divided by now 300 hours. So if we set this up with long division, which I'm going to do, it really would be 6 divided by 300. Now, last time I checked, 300 does not go into 6 right there. So really, you could just say that you have a remainder of 6, which we don't really want either. And we definitely don't want to go into decimals yet. So I'm not going to worry about the rest of this. As a fraction, if we wanted to, even though I don't really want fractions yet, it'd be 6/300ths or 1/50th. Again, don't worry about that math right there. We'll get to it. But it's asking, are the numerical answers the same? No, 50 miles per hour is much different than this less than 1 mile per hour. It's very small. So this answer here is no. No, they are not the same. And again, this goes back. I guess it's trying is what I should say. It's trying to show a commutative property of division. But there isn't one. Boom. .9, putting it all together. So we're looking at order of operations. That was the big one. And then translating and solving, not as big, but big enough.